SGV Mahesh PU College, Belagavi. I welcome to the Department of Chemistry. Classification of crystalline solids. Let's consider the types of crystalline solids. Based upon the types of constant particles and the interaction between the constant particles, crystalline solids are classified into first one molecular solids, second one ionic solids, third one metallic solids, and the fourth one is covalent solids. Let's start with the first one, molecular solids. Molecular solids. As the name itself indicates, molecules are the constant particles of molecular solids. These are further subdivided into the following categories. First one is non-polar molecular solids. In non-polar molecular solids, the constant particles are either atoms such as helium, argon, neon, or the molecules such as hydrogen, chlorine, iodine. Any molecules which are having non-polar covalent bonds can be taken as example. In non-polar molecular solids, the force which is acting is dispersion force or London force, which is very weak force. Second type is polar molecular solids. In polar molecular solids, the constant particles are containing polar covalent bonds. The molecules are held together by relatively stronger interaction called as dipole-dipole interaction. Previously, in non-polar molecular solids, there is a weak force of interaction called as dispersion force or London force. But in polar molecules, there are relatively stronger interaction called as dipole-dipole interaction. Example for polar molecular solids are HCl and SO2. Third one is hydrogen bonded molecular solids. In this, the molecules are having hydrogen bond. The hydrogen bond is present between hydrogen and fluorine or nitrogen or oxygen atoms. There must be a bond between hydrogen and the most electronegative elements such as fluorine, nitrogen or oxygens. Example is ice. In ice, there is a hydrogen bond between hydrogen and oxygen of water molecule. To understand molecular solids, we'll consider one problem. Which one of the following is a molecular crystal? Rock salt, quartz, dry ice, and diamond. The correct option is dry ice. The solution is dry ice is a molecular solid. Dry ice is nothing but solid carbon dioxide, which is a molecular crystal. And the next one is rock salt. Rock salt is nothing but NaCl, is an ionic crystal because there are two ions, Na plus as a cation and Cl minus as an anion. Hence it is a ionic crystal. Next, quartz and diamond. Both are covalent crystal because there is a covalent bond between carbon and carbon in both quartz and diamond. Hence, the correct answer is C, that is dry ice, nothing but solid carbon dioxide. Ionic solids. In ionic solids, the constituent particles are ions. Cations and anions are the constituent particles, and these are held by strong force called as Coulombic force or electrostatic force of attraction. Example for ionic solids are sodium chloride, zinc sulfide, magnesium oxide. Any ionic solids can be taken as example. Third one is metallic solids. In metallic solids, the constituent particles are positively charged metal kernels in a sea of free mobile electrons. Example is zinc, sodium, etc. Any metals can be taken for the metallic solids. Here is the view. Here the metal kernel consists of electrons which is embedded in the sea of free mobile electrons. This is the arrangement of metal kernels in the sea of free mobile electrons. Fourth one is covalent or atomic or network solids. In covalent solids, the constituent particles are covalently bonded non-metallic atoms. Example is diamond and graphite, where there is a bond between carbon and carbon through a covalent bond. We will take one example. Which of the following exist as covalent crystal in the solid state? Options are phosphorus, iodine, silicon, and sulfur. Out of this, which exists as covalent crystal in the solid state? Answer is silicon. Let us consider the solution. Silicon exists as a covalent crystal where silicon is bonded to another silicon with a covalent bond. Phosphorus, iodine, and sulfur exist as a molecular solid as P4. Phosphorus is existing as P4, iodine is existing as I2, and sulfur is existing as S8 respectively. Hence, answer is C, that is silicon is the correct option. Now we will consider all kinds of solids in the form of table. Types of solids, constant particles, bonding or attractive force, examples, physical nature, electrical conductivity, and melting point. First, we'll take molecular solids. In the molecular solids, again, we have three types. First one is non-polar molecular solids. Here, the constant particle is non-polar molecules, and the bonding or the attractive force is dispersion force or London force, which is weak force of attraction. Example we have CCl4, H2, I2 and carbon dioxide. Physical nature is it's a soft one because the force of attraction is weak. Electrical conductivity, they are insulator, they do not conduct electricity. Melting point is very low. Next one is non-polar molecular solid is the first one. Next one is polar molecular solids. In this one, the constant particle is polar molecules. Here the interaction is a strong interaction, dipole-dipole interaction. Example is HCl, SO2. Physical nature, here it is soft. Electrical conductivity, again it is a insulator. Melting point is low. Next one is hydrogen bonded molecular solids. Here the constituent particle is hydrogen bonded molecules. Bonding is hydrogen bond. Example is H2O. Particularly we call it as ice. Physical nature, it is a hard, and the electrical conductivity, it is an insulator. The melting point is low. The second type of crystalline solid is ionic solid. Here the constituent particles are ions, that is cations and anions. The attractive force is electrostatic force or Coulombic force. Example is NaCl, MgO, ZnS and CF2. There are many examples, but some examples we are taking. The physical nature is hard and but it is brittle. The electrical conductivity is very important. They are insulator in solid state, but they conduct in molten and in aqueous solution. They conduct electricity in molten as well as in the aqueous medium, but they don't conduct electricity in solid state because there is no free ions there. Melting point, which is very high because there is a strong force of attraction called as electrostatic force of attraction. Next one is metallic solids. Here the constituent particles are positive ions in a sea of mobile electrons, and positive ions, it is also called as metal kernels. The attractive force is metallic bonding. Example, we can take any metals such as Fe, Cu, Ag. Any examples of metals can be taken. The physical nature is hard but malleable and ductile, which is a very unique character of this metallic solids. Electrical conductivity, they conduct electricity in solid as well as in molten state. In both the cases, they conduct electricity. The melting point is fairly high. Covalent or network type of solids. The constituent particles are atoms, the covalently bonded atoms. The attractive force is covalent bonding. Examples are quartz, that is SiO2, silicon carbide, SiC, and the diamond C and ALN. They are hard and they do not conduct electricity. That's why they are insulator. But one exception case is that is graphite, which conduct electricity. The melting point is very high. This is about all kinds of solids, and here what you have to concentrate is different types of solids and their examples, and the different types of constituent particles, as well as different types of attractive force which is present in different kinds of solids, that you have to concentrate, that can be asked in the examination.